Hi guys, I'm back for part C of lesson 89. You'll recall we were on we did part A and B in our last video, conjunctions and disjunctions, and now we're ready for part C. I'll give you a little update. It's about 6:30 Malaysia time, and the sun goes down and it starts to cool off, and then people come out and play a little bit more because it's so hot during the day to do that. So there's kids playing in the pool, and there's like a 4-square court or something just outside the window, 14 stories down. So they're all outside playing, and it's really cute. All right, let's review a little bit of geometry. This is one of those lessons where they spend a lot of time on theoretical proofs, and I don't really care right now about theoretical proofs because it's more important to me that you guys know how to do the calculations, and if you care deeply about this, you can learn about the proofs later. So let me remind you what happens when we have two lines that intersect in a circle, and we want to find, say, the measure of that degree, that angle. We would know that these two angles were the same, and what we would do is we would measure what we call the intercepted arc on both sides. Let's say that this is 90 degrees and this is 80 degrees. We would add those two up, 80 plus 90, and we would divide it by 2, which would be 170 over 2, and that would be what? 85 degrees. So we would know that the measure of this angle, an inscribed angle created by two chords, we add and divide by 2. What about if we have a circle and we have an angle that is outside of the circle? Pretend that's a tangent. I don't want that to be touching right there. Here, if we want to know the measure of this degrees, say this is 90 and this is 120, we would take the bigger side, 120, we would subtract the smaller side, 90, and then we would again divide it by 2. So that would be 30 over 2. Well, let me just change this. What I'm doing is still true, but let me just change the numbers so they match what the book has. I accidentally read that number wrong because my eyes are still crazy. So I want your notes to match what's in the book. So 170 minus 90 would be 80 divided by 2, and that would be 40 degrees for this. All right. The process is, I was doing the process correctly. I just want to make sure that my problem matches. Okay, so now what we're going to do is we're going to talk about similar kinds of triangles, or circles rather, lines within the circles, but we're going to talk in slightly different terms. Let's say we've got these two lines that intersect within the circle, kind of like last time, but instead of talking about the degrees and the angles, we want to talk about the length of the segments. What we can find is that there will always be a relationship between these. Okay? So let's say that those are the lengths of the segments in our circle. What we can do is that we multiply the two that are on the same line, so in this case 2 times 6. That will be equal to the two segment lengths on the other side. And they set this properly up for us so that we get 12 times 12. So there's a check, right? It makes sense. Yay! We can use this to solve algebraic problems within the geometry if we look at something like this. 3, 5, 7, and x. In this case, what they're asking us to do is use this interesting product rule to solve for x. So we would know that 3 times 7, the lengths of one chord, are going to be equal to, the product is going to be equal to these two, 5 times x. So then it's just a simple matter of solving. 21 equals 5x. So in this case, this segment of the chord is going to be 21 over 5. All right? So that shows how we would use this rule to solve a simple little algebraic problem. Let's make it a tiny bit more tricky. I'm always good for more tricky. All right, I'm still on 89.C. And these aren't even examples yet. They're just pictures they're showing us. What happens if we have one of these external angles? Again, we're not talking about the degrees anymore. We're talking about the lengths of the segments. They work something like this. Let me show you. What we do is we multiply the length of the outside piece, 3, times the length of the total piece, 3 plus 5, and we set that equal to the outside segment, 2, times the length of the total plate piece, 2 plus 10. Make sense? The outer piece times the whole equals the other outer piece times the whole. Let's see if it works. 3 times 8 equals 2 times 12. Oh, John. He's so good, isn't he? Whoops, I wrote 25. I meant 24. Whoops, sorry, I'm sliding away on my slippery Malaysian tile floor. Okay, and then obviously we can use this same scenario to solve algebraically. Let's take a look. This is still in the book. 4. Do you hear the motorcycle? I bet you do. 3 and 5. Okay, so these are pretty straightforward, but there's a little trick here. The outside piece, 4, times the total piece, 4 plus x, right, we're adding, will be equal to 3, the outer piece, times the total, 3 plus 5. Yeah? Then we multiply. 16 plus 4x equals, this is 8, 24. Yes? Then we subtract 16 from both sides. 4x equals 8. And x equals 2. Why do they have... Yes, that's right. Sorry. They didn't solve it in the book. All right, and then the last little wrinkle of this that you need to know in order to solve the problems is, what if you have something that looks like this? And I'm trying to draw these quickly on the fly, okay? Like so, okay? It goes like that. It doesn't actually go into the circle like this one, so we have a tangent here. So how do you deal with those? Well, there's a nifty little trick. 8, okay? This time, we do the same thing with this part. We take 4 times the total, 4 plus x, and since there's only one number to this one, we square it. We multiply it times itself, okay? This is important that you know how to do this. This is what the problems look like in this section of the chapter. So you square this little dude all by himself, all right? And then to solve it, easy, 16 plus 4x equals 64. (4x) equals 48x. Whoops, sorry. I wrote the wrong thing down. X equals 12. All right? So the trick is, with these tangents, you square them. All right? The rest of this section in the book is devoted to proving why this makes sense, why it makes sense to square it. If you would like to invest some of your brain space in a perfectly thorough explanation of why squaring it will work, feel free to go ahead and tackle page 371 and the top of 372. If you're happy just to know that that's the process and you're comfortable with these two calculations, then you are good to go on. There aren't even any examples for this, you guys, so just go right into the homework for lesson 89, and I will talk to you next time.